Hello, once again I welcome you to my YouTube channel. I still remain Alira Daniel. I thank you for watching my videos, for subscribing, and also for liking. Not only that one, but also for forwarding the links to other members. I believe you guys are enjoying the lessons, and I believe they are moving on very well. Today, we are going to see stationary wealth. In our previous lesson, we had been discussing progressive wealth, but today we shall see stationary wealth. A recap of what we saw: we said that a progressive wealth is that one that moves from one point to another, and energy is carried from the source to the surrounding areas. And as it does so, energy is lost to the surrounding, and for that case, we said the amplitude of a progressive wave keeps on reducing as it moves away from the source. What about stationary waves? When talking about stationary waves, somebody can as well call it to be standing waves. A standing wave is that one which does not move along the medium. It is that type of wave where energy is not transferred from one point to the other point. The particles of the medium do not move from one point to the other point along the wave profile. And they are formed when two progressive waves, with these two progressive waves, must be moving in opposite direction. These two progressive waves must have the same amplitude, they must have the same frequency, they must also have the same velocity, but moving in opposite direction. So when these two progressive waves move in opposite directions superpose or meet, what is formed is what called to be a standing wave or a stationary wave. So let's consider a progressive wave which is moving from left to right. We have a progressive wave moving from left to right. Let me call this to be wave 1. If this wave 1 is superposed with another progressive wave which is moving from right to left, let me call this one to be wave 2, moving from right to left. This one is moving from left to right. So when these two waves meet, what is resulted is standing waves or stationary waves. A stationary wave is categorized by a point of maximum displacement, which is called to be antinode, and a point of minimum displacement, or in any case it may be zero displacement, which is called to be node. So on a standing wave we have nodes and anti-nodes. So how do we define a stationary wave then? We can say a stationary wave is that type of wave which is formed when two progressive waves of equal amplitude, same frequency, same velocity, traveling in opposite direction superpose or meet, resulting in two antinodes and nodes. That would be the definition of a stationary wave. How is an antinode formed and how is a node formed? We shall have an antinode formed when these two waves meet when they are in phase. When we are discussing progressive waves, we talked about phase. So when they are in phase, when these two waves meet when they are in phase, there is that point of maximum displacement which will be formed, and that is antinode. There we say that there is reinforcement taking place, and so there will be maximum displacement. What if they meet out of phase? That possibility is also there. When they meet out of phase, there is always cancellation. So the cancellation leads to the formation of a node. This can best be demonstrated when you have two loudspeakers. We have a loudspeaker this side and another loudspeaker the other side. But these two loudspeakers are getting sound from the same source. That means that the sound produced by this loudspeaker and the other loudspeaker will have will have the same speed, same velocity, same amplitude. Reason being, they are from the same source. So as this one is producing its wave, the wave will travel along that. This one also produces its wave, it will also travel along that. Now eventually, if you walk between these two loudspeakers along the line, joining these two loudspeakers, you will realize that at a particular point you will hear a very loud sound. Where you hear a very loud sound, that's where an antinode has been formed. Then as you also walk along the path, you will realize that there is a point where there is a very low sound or even completely nothing. That point is what going to be the node. So you will find you will have alternate region of maximum intensity, zero intensity, maximum intensity, zero intensity, maximum intensity, zero intensity as you move along. So that's as those are formed as a result of cancellation and reinforcement of wave. So that's briefly what a stationary wave is, how it is formed, and the characteristic of the wave itself. Let's see how stationary waves are formed. Here we have a question. How are stationary waves formed? When we describe the formation of stationary waves, we can say stationary waves are formed when two progressive waves of equal amplitude, same frequency, and same speed meet, resulting into formation of antinode and nodes. Antinodes are formed when two waves meet in phase and we have maximum amplitude at that point. Meanwhile, nodes are formed when two waves meet out of phase and at that point we have minimum or zero amplitude. So that's how they are formed. So this is how stationary waves are formed. We are saying here that stationary waves are formed when two progressive waves of equal frequency and amplitude traveling in opposite direction are superposed. When you talk of superposed, you say meet. Are superposed, resulting into formation of antinodes and nodes. Please don't forget we're saying that at antinodes, waves meet in phase and the amplitude is maximum. Meanwhile, at nodes, waves meet out of phase. It is supposed to be out of phase. Waves meet out of phase and the amplitude is minimum. So that's how stationary waves are formed. Basically, you need two progressive waves which must be traveling in opposite direction. But these two progressive waves must have the same amplitude and the same frequency and moving at the same speed. When they meet, automatically you have stationary waves formed of standing waves. Let's see the conditions for stationary waves to be formed. There are basically two conditions for stationary waves to be formed. One of which is that you don't forget that you say stationary wave, there must be two progressive waves which are moving. So one of the conditions is that those two progressive waves must be traveling in opposite direction. Then the second condition for a stationary wave to be formed is that the two progressive waves which are going to be meeting, of which they are traveling in opposite direction, must have the same frequency, same speed, and the same amplitude. So those are the basically two conditions necessary for you to have the stationary wave form. Saying two waves must be traveling in opposite direction. That is one. Two, the two waves must have the same frequency, same amplitude, and same speed. As simple as that. Those are the conditions necessary. Let's look at the representation of a stationary wave. As earlier on discussed, we said that if a progressive wave is traveling from left to right, then the other one must be traveling from right to left. When they superpose, then we shall have stationary waves. I told you that it's categorized by antinodes and nodes. This is how it's represented. The representation, you see, it has the point of maximum displacement, which is the antinode, and the point of minimum displacement or zero displacement, which is the node. Maximum displacement, minimum displacement, maximum displacement, minimum displacement. This is the representation of stationary waves. If we are to define those antinodes and nodes, we are saying by definition, an antinode is a point of maximum displacement. It's a point of maximum displacement on a stationary waves. And when does it occur? I told you, it occurs when two waves meet when they are in phase. So we're saying that the point of maximum displacement on a stationary wave, and it occurs when the two waves meet in phase. That is an antinode. Then we have a node. A node is a point of minimum. If not minimum, then zero displacement on a stationary wave, and it occurs when the two waves meet out of what? Out of phase. So that's briefly about representation of stationary waves. Let's look at some of the differences between progressive waves and stationary waves. Of course, they are not the same, much as stationary waves are formed when two progressive waves superpose, but they cannot be the same. One of the differences between progressive waves and stationary waves is that for a stationary wave, the particles of the medium, particles of the wave, which is the particles of the medium, different particles vibrate at different amplitude. You find particle A is vibrating with a certain amplitude, particle B is vibrating with another amplitude, but along the same medium. What about for progressive waves? You find all particles are vibrating at the same amplitude. Let's say 2 meters, then all of them will vibrate at 2 meters at a particular point. If 3 meters, all of them will vibrate at 3 meters. Unlike in stationary waves where others are vibrating at 3 meters, others are at 2 meters, and so forth. So that makes a difference between the two. Then another difference comes in like energy which is transferred along the medium. We said in stationary waves, energy is not transferred from one point to the other point, but rather it is just confined at a particular section. But when it comes to a progressive wave, energy is transferred from one point to another along the wave form. Now, one of the differences is that their characteristics. Stationary waves are categorized by nodes and antinodes. And on the other hand, you realize that progressive waves are categorized by crest and troughs. So the table below shows the differences between the two. We have stationary waves on one side and progressive waves on the other side. So on this side we are saying that the amplitude of the particles varies with position along the medium, and on the other side all particles vibrate at the same amplitude. Next is that the energy is not transferred. That is under stationary wave. Energy is not transferred from one point to another medium, while the reverse is true on progressive wave. The last leg is in their characteristics, saying that for stationary wave it consists of nodes and antinodes, and here it consists of crest and trough. So those are the differences between progressive waves and stationary waves. It is also important to note that the distance between two consecutive nodes or antinodes on a stationary wave is a half wavelength. When you're discussing progressive waves, you say that the distance between two consecutive crests or troughs was equal to what? Wavelength. But when talking about stationary wave, the distance between two successive nodes or antinodes is equal to wavelength divided by 2. That is half wavelength. Our lesson for today is ending here. I believe you enjoyed the lesson. Please don't miss the next lesson, which will be principle of superposition of waves, and from there we shall see how we can get the equation of stationary wave. Thank you for watching. Goodbye.